In the opening months of 1940, long before the full scale of global conflict became clear, wartime planners faced a brutal reality. The world was changing faster than their factories could keep up. Nations that once relied on slow, methodical production suddenly needed machines, parts, and ammunition at a pace never seen before. Inside the walls of newly constructed industrial facilities, the pressure to deliver was immense. Every hour lost meant a wider gap between supply and demand, and that gap could shape the fate of entire campaigns. These facilities, often built in remote regions to protect them from potential air raids, were more than production spaces. They were ecosystems. Dense, self-contained worlds where thousands of men and women lived their daily routines under strict wartime discipline. Inside, the air carried a mixture of metal dust, machine oil, and tension. Every worker knew that mistakes were not just errors, they were vulnerabilities in a nation's defensive armor. The core problem was simple yet immense: how to convert traditional, slow-moving industrial culture into an almost militarized production rhythm. Before the war, factories ran on predictable schedules, with modest expectations and generous timelines. But in 1940, those habits no longer fit the scale of the threat. Engineers, administrators, and labor forces had to evolve rapidly, transforming ordinary workplaces into high-output engines capable of sustaining entire armies across continents. Inside these wartime facilities, daily life grew increasingly regulated. Management introduced rigid systems to eliminate inefficiency: scheduled tasks, mandatory inspections, continuous machine checks. The old sense of factory life disappeared, replaced by the constant hum of urgency. This was not about meeting quotas, it was about ensuring survival. And beneath all of this lay a deeper challenge. These workers were human beings facing extraordinary pressure. While governments counted their output in tons, the workers counted the minutes until the next break, the next shift change, the next opportunity to breathe outside the walls. Their lives, though vital, were often invisible. Yet it was here, in these unseen routines, that the foundation of wartime production was built.
By 1940, Europe had already plunged deeper into conflict, and the tremors of global war shook nations far beyond the battlefronts. Industrial planners realized that modern warfare required more than bravery on the field. It needed a relentless flow of precision-engineered supplies. From aircraft engines to communication equipment, each component had to arrive reliably, without delay. This urgency reshaped factories around the world. Facilities were reorganized with military-like precision. Administrators adopted methods inspired by assembly line logic, but intensified by wartime necessity. Engineers redesigned workflows, grouping machines by purpose, arranging tools in standardized layouts, and mapping production sequences down to the smallest gesture. Efficiency was not just desirable, it became doctrine. For those laboring inside the facility became a world of its own. Many arrived before sunrise, standing in organized lines as supervisors conducted attendance checks. Roll calls were conducted with the seriousness of military formations. The clang of shift bells echoed across the compound, signaling transitions with mechanical consistency. Some workers lived in nearby barracks, while others commuted from cramped wartime housing units built hastily to accommodate growing labor pools. Nutrition, rest, and morale were also strategically managed. Canteens served meals high in carbohydrates and fats to support long hours of demanding physical labor. Posters on the walls reminded workers of national duty, encouraging concentration, vigilance, and discipline. These messages created a rhythm that merged patriotism with routine. Over time, many workers felt both pride and pressure, motivated by the belief that their labor contributed directly to the war effort, yet burdened by the unyielding expectations placed upon them. Within this context, daily life inside a wartime industrial facility became a microcosm of the greater struggle, a battle fought not with rifles, but with rivets, gauges, and grinding wheels. Daily operations inside a 1940 wartime industrial facility unfolded with relentless precision. Before the machinery reached full roar, workers filed into the main hall, moving past inspection tables where foremen checked tools, badges, and work logs. Everything began with calibration. Technicians verified gauges, inspected belt tensions, and examined lubrication points along the assembly lines. Even minor deviations were logged, analyzed, and corrected before production truly began. Because in wartime, one misaligned measurement could compromise an entire shipment. As the morning advanced, the facility transformed into a living organism. Conveyor belts moved steadily, carrying metal casings, gear components, and unfinished assemblies from station to station. Workers developed a rhythm that blended instinct with training, performing repetitive tasks with remarkable consistency. Overhead, the clatter of pneumatic tools echoed through the rafters. Sparks from welding bays illuminated the dim industrial corridors, each flash a reminder of the scale of work underway. Supervisors moved constantly through the facility, observing workflow, checking log sheets, and listening for irregularities in machine sounds. Their responsibility was not just oversight, but anticipation, detecting inefficiencies before they escalated into breakdowns. At scheduled intervals, quality inspectors examined completed parts, using micrometers, calipers, and comparative gauges to verify tolerances. While workers focused on speed, inspectors became guardians of precision, ensuring every item met the strict standards demanded by wartime engineering. Breaks were brief and strategically timed. Workers often ate in silence, conserving energy, knowing the day's pace would not slow. Returning to their stations, they re-entered the relentless rhythm of production. Hours passed in a blur of metal, motion, and repetition. Only shift changes interrupted the pattern, bringing a fresh wave of laborers into the fray. By midday, the facility reached its peak intensity. Heat radiated from engines, furnaces, and overworked motors. Ventilation systems strained to keep the air breathable. Yet, despite the hardship, workers pressed on, driven by a sense of duty, aware that every component they produced would soon find its place in the machinery of war. Crisis inside a wartime industrial facility rarely announced itself dramatically. Instead, it often began with something small, a slight tremor in a gearbox, an unexpected resistance in a conveyor belt, or an anomaly in a quality control measurement. On one particular day, it started with a machinist noticing that a set of precision bearings was failing inspection more frequently than usual. The tolerance deviation was slight, but enough to raise suspicion. Investigators quickly gathered samples and compared them against the previous day's logs. The issue was spreading across multiple workstations, not isolated, but systemic. A critical grinding wheel had worn unevenly, causing micro defects that were nearly invisible to the naked eye. If these faulty bearings had been shipped, they could have endangered equipment on the front lines, risking catastrophic failures at crucial moments. As managers assessed the situation, tension spread across the facility. Production was halted in sections, creating a sudden interruption in the otherwise relentless workflow. Workers gathered in clusters, murmuring about potential consequences. Every minute of downtime meant falling behind schedule,
and restoring output required both speed and accuracy. The crisis deepened when inspectors realized that the flawed components had already been boxed for shipping. Entire crates had to be retrieved, opened, and re-examined. Time was slipping away. Supervisors coordinated a full-scale inspection sweep, calling in additional staff to analyze thousands of parts. The piercing alarm that signaled production suspension echoed through the facility, a rare and unsettling sound. Engineers conducted rapid diagnostics, mapping the defect pathway backward through the production line. As stress mounted, each specialist worked within their narrow window of expertise. This was not merely a technical problem. It was a threat to the integrity of the entire wartime supply chain. And in a facility where every hour counted, the crisis forced the workforce to confront an uncomfortable truth. Even the smallest flaw could ripple outward, impacting battles far beyond the factory walls.
Diagnosis began with a methodical dismantling of the affected production line. Engineers and toolmakers gathered around the grinding station, removing panels, examining bearings, and measuring spindle drift with dial indicators. The goal was to identify the exact point where precision had faltered. Under bright industrial lamps, they scrutinized each component, searching for hairline fractures, heat discoloration, or minute irregularities. Eventually, the root cause emerged. The grinding wheel, though within its expected lifespan, had been subjected to unusually heavy workloads over several consecutive shifts. Micro-imbalances developed, causing uneven abrasion patterns. These produced subtle distortions, small enough to pass initial checks, yet significant enough to undermine long-term reliability. Once discovered, the engineers debated solutions: replace the wheel entirely, recalibrate the spindle, or redesign the workflow to reduce stress on the machine. Meanwhile, quality control teams compiled data, creating detailed reports of every affected part. They charted defect rates, timelines, and operator logs. This information formed a map of the problem, guiding decisions about whether to rework or discard flawed components. Supervisors reviewed the data with urgency, aware that every delay further strained an already tight schedule. Workers contributed their experiences as well. Machine operators described slight changes in vibration and sound, observations that seemed inconsequential at the time, but now offered critical clues. Toolmakers proposed adjustments to tool geometry, while maintenance crews inspected the facility's lubrication distribution network, ensuring adequate flow to every critical point. The entire diagnosis effort was a coordinated operation, combining human intuition with technical expertise. As clarity emerged, the facility prepared for corrective action. Replacement wheels were retrieved from storage, and technicians began calibrating the new assembly, ensuring perfect balance before installation. Inspectors prepared fresh testing procedures to verify that restored components would meet wartime standards. In diagnosing the crisis, the facility demonstrated its underlying strength: adaptability. Through teamwork, precision, and discipline, the workforce transformed a potentially disastrous setback into an opportunity to reinforce the reliability of the machines that would soon serve far beyond the factory walls. Implementation unfolded with military-like coordination. Maintenance crews, armed with specialized tools, removed the worn grinding wheel and cleaned the entire assembly with meticulous care. Engineers took measurements at every step, ensuring the new wheel met exact specifications. Workers monitored spindle rotation, verifying balance with precision instruments. Nothing was left to chance. Once installation was complete,
Supervisors authorized a controlled restart of the production line. The hum of machinery began softly at first, rising in intensity as technicians watched for unusual vibrations or temperature spikes. Quality inspectors hovered nearby, ready to analyze the first batch of parts produced under the corrected setup. As production resumed, workers synced their tasks with renewed attention. Operators documented machine behavior, noting sound patterns, heat levels, and feed rates. Foremen cross-checked these logs with maintenance crews, ensuring consistency. The focus was not merely speed, but absolute reliability, a non-negotiable standard in wartime manufacturing. Parallel to the mechanical adjustments, administration teams revised internal protocols. They introduced new rotation schedules for high-stress machines, ensuring that no single unit would be pushed beyond safe limits. Training officers held briefings for workers, emphasizing the importance of reporting minor irregularities immediately. The crisis had revealed a vulnerability, and the facility was determined not to repeat it. Gradually, confidence returned. The new grinding wheel functioned flawlessly, producing bearings with exacting precision. Inspectors confirmed tolerances across multiple samples, establishing that the line had not only recovered but surpassed previous standards. The pace of production quickened, driven by both urgency and restored morale. Implementation was more than a repair, it was a renewal. The workers understood that their efforts directly strengthened the wartime supply chain. By responding swiftly and decisively, the facility reaffirmed its place as a vital link in a global struggle, one sustained not only by armies, but by the quiet determination of those who labored in places like this.
The impact of the restored production line rippled outward almost immediately. Crates filled with newly manufactured precision components began flowing out of the facility with steady confidence. These parts traveled across rail networks, through shipping docks, and into military assembly plants, where they became essential elements of aircraft, vehicles, and communication equipment. What had nearly been a supply chain failure was now a symbol of recovery. Within the facility, morale improved. Workers took pride in the fact that they had helped avert a potentially serious setback. Supervisors acknowledged their dedication, using the event as evidence of the value of vigilance. Regular briefings highlighted the restored stability of the production process, reinforcing the message that even under immense pressure, the workforce could adapt and overcome. The crisis also prompted higher-level changes. Wartime planners reviewed the incident and used it as a case study for other industrial sites. They encouraged factories across the nation to adopt similar inspection protocols, emphasizing the need for early detection of mechanical fatigue. The event became a quiet but influential lesson in the importance of disciplined maintenance, an idea that spread far beyond the walls of the original facility. The improved workflow also increased output. Engineers noted that the recalibrations had actually enhanced efficiency, leading to marginal but meaningful gains in precision and durability. These improvements accumulated quickly, producing a measurable effect on the facility's overall productivity. Most importantly, the workers themselves felt the significance of their actions. For many, the impact was not merely technical, but personal. They understood that their labor, though unseen by the public, played a critical role in the broader fight. Each successful part that left the facility carried a piece of their effort, becoming a silent contribution to the war effort unfolding far away.
The legacy of 1940 wartime industrial facility endured long after the conflict ended. What began as a temporary solution to an urgent problem evolved into a milestone in industrial organization. Many of the processes developed under pressure: strict quality control, predictive maintenance, streamlined workflows, later became foundations of modern manufacturing. Workers who once toiled under wartime urgency returned to civilian industries with new expectations of discipline and efficiency. Their experiences reshaped factories in peacetime, raising standards across entire sectors. Engineers who refined production under extreme constraints went on to lead innovations in aerospace, automotive manufacturing, and industrial design. Historians looking back saw these facilities as quiet powerhouses. While battlefields captured public attention, it was the labor inside these factories that sustained armies, supplied fleets, and ensured the continuity of national defense. The lessons learned about teamwork, resilience, and precision became part of the invisible framework that shaped future industries. The facility itself, long after the war, transformed into a symbol of industrial heritage. Some sections were preserved as museums, others repurposed for modern use. Yet within their walls, echoes of the past remained: the rhythmic clatter of tools, the hum of conveyors, and the unyielding determination of those who once labored there. In the end, the legacy of life inside a 1940 wartime industrial facility was not defined by machinery alone. It was defined by people, ordinary individuals who faced extraordinary demands. Their contributions, often hidden and unsung, formed the backbone of a global effort. Through their work, they demonstrated that victory in war depends not only on those who fight, but also on those who build, repair, and persevere in the relentless pursuit of precision.